So this is a National 4, National 5 chemistry lesson. We are on the topic acids and alkalis in Unit 1. And today's lesson is going to actually be two lessons combined. And we're going to look at the sources of acids, which are going to be our non-metal oxides, and our sources of alkalis, which will be our metal oxides. So for the first part, we're going to discover what happens when non-metal oxides dissolve in water, and we're going to understand the environmental impact of acid rain. In terms of success criteria, we would hope that you can state that non-metal oxides dissolve to form acids. You can state that acids make up acid rain and be able to give some of the sources of the acids in acid rain. State the impact of acid rain and state ways to reduce acid rain. So, non-metal oxides produce acids, and the most common sources of non-metal oxides, or the elements that they're based on, are carbon, nitrogen, and sulfur. Now, those are the non-metals. A non-metal oxide means that that element has reacted with oxygen. So when carbon reacts with oxygen, we get CO2. When nitrogen reacts with oxygen, we can get NO2 or sometimes NO. And when sulfur reacts with oxygen, we get sulfur SO2. Now the names of those compounds are carbon dioxide, nitrogen dioxide or nitrogen monoxide, and for sulfur, sulfur dioxide. Whenever these dissolve, so non-metal oxides are gases, and whenever they dissolve, they produce acids. The names of the acids produced from these are carbonic acid is made when carbon dioxide dissolves in water, and that's one of the acids found in fizzy drinks, but it's also one of the acids found in acid rain. Nitric acid is produced whenever nitrogen oxides dissolve. And when sulfur dioxide dissolves, you can get sulfurous or sulfuric acid. Now, where do these non-metal oxides come from? Well, there are man-made sources of non-metal oxides. Whenever we burn fossil fuels, they release carbon dioxide. Some fossil fuels also contain sulfur and will produce sulfur dioxide. In cars, car exhaust fumes can contain nitrogen oxides. So the NOx, that represents both NO and NO2. And car exhaust fumes also release carbon dioxide because you're burning petrol. And whenever we make certain chemicals, we can end up releasing gases into the atmosphere. And one of the common gases released during the manufacture of other chemicals is sulfur dioxide. And there are also natural sources of non-metal oxides. So whenever we talk about greenhouse gases or gases causing acid rain, which are similar to one another, there definitely is a bigger component that comes from the effects of man, but there are also natural sources which do make up a significant proportion of the gases that make acid rain in our atmosphere. So all living things do a process called respiration. That's how we get energy out of food, and we breathe out carbon dioxide. That contributes to the total amount of carbon dioxide in the air. And volcanoes. So volcanoes are the biggest single source of sulfur dioxide. But when you put together all the other processes that release sulfur dioxide, man releases more sulfur dioxide than volcanoes, but volcanoes themselves release a lot of sulfur dioxide. So the rain around places with volcanoes tends to be a bit more acidic than other places on the Earth. What are some of the consequences of acid rain? Well, acid rain can destroy buildings. So certain stones, particularly sedimentary rocks, will react with acid, and it can start to very slowly dissolve away buildings and statues. And you will have definitely seen some statues that look as though they've seen better days, that some of the features are starting to disappear. That is a consequence of acid rain. If we have high amounts of acid in the rain, it can make soil more acidic. And this can lead to fertilizers not staying in soil as easily and flowing into rivers, which can cause an algae bloom. But also, if we acidify soil, we are affecting the habitats of animals, and it can lead to loss of biodiversity. As well as acidifying soil, acid rain can acidify rivers, lakes, and oceans. And this is particularly dangerous anywhere where there is a coral reef. If you've seen any of the pictures of coral reefs that look dead, where all the coral has turned white, that bleaching of the coral reefs has been caused by acidification of oceans, which leads to a massive loss of biodiversity and a significant death of animals. And this eventually will have an effect on us, as there will be less fish and therefore less food for certain places to provide their populations with sufficient food. Now, there are ways in which we can prevent acid rain, so it's not all doom and gloom. By promoting and using more green or renewable sources of energy that don't rely on burning fossil fuels, we can release less sulfur dioxide, carbon dioxide, and nitrogen oxides into the air. That will limit acid rain. Cars are now typically fitted with these things called catalytic converters, which prevent nitrogen oxide and nitrogen dioxide from getting into the air. And by using more public transport, using trains, buses, or cycling to get to work, to school, etc., that minimises your individual impact on acid rain. And also, governments can help by introducing stricter regulations on the amount of gases that factories and companies can release. So, if you're in class, you may have been able to measure the pH of your breath, which contains carbon dioxide, and so you should hopefully have seen that it is acidic. By the end of this part of the lesson, you should hopefully be able to say that non-metal oxides dissolve to produce acids. So remember, non-metal oxides dissolve to give acids. Non-metal oxides dissolved produce acids that can form acid rain. Acid rain has negative impacts on soil, on oceans and rivers, and destroys certain buildings and statues. And acid rain can be reduced by using less fossil fuel, by using more public transport, through government regulation, and through increasing the use of catalytic converters on cars. The second part of this lesson is going to focus instead of on non-metal oxides, but instead of metal oxides. And hopefully in class you'll have the opportunity to try and dissolve a series of metal oxides and see what pH they come to, and be able to compare what happens to water if you add a soluble metal oxide compared to if you add an insoluble metal oxide. In terms of success criteria, we would hope that you would be able to say that soluble metal oxides produce alkaline solutions, but insoluble metal oxides do nothing to the pH of a solution. So metal oxides in water. Metal oxides that dissolve form alkaline solutions. And remember that alkaline solutions are determined either using universal indicator or universal indicator paper, and you would notice a colour change to dark green, blue or purple. However, if you add an insoluble metal oxide, nothing will happen. Your universal indicator will stay light green, representing pH 7. And that's because only chemicals that dissolve can change pH. So an insoluble metal oxide, something like iron oxide, will not change the pH. You need to be aware that page 8 of your data booklet has a big table, and on that table, if you look at the column that's titled oxide and look down the range of metals in that column, you can use that to determine whether or not a metal oxide is soluble or not. If that metal oxide is soluble, it will be an alkali. If that metal oxide is insoluble, it will not do anything to the pH of a solution. So hopefully, I know it was a very brief lesson there, but you will be able to say that soluble metal oxides dissolve to form alkaline solutions, and be able to say that insoluble metal oxides will not affect the pH of solution. So we have got some show me questions, and just a couple to see what you can remember. So first one, true or false? All metal oxides produce alkali solutions. Well, hopefully you would say that that one is false, but the next question is, why is that false? Why do not all metal oxides produce alkali solutions? Well, the answer is some metal oxides are insoluble, and any metal oxide that's insoluble does not affect pH. And a final question, non-metal oxides that dissolve will form what? Non-metal oxides dissolve to form acids. So non-metal oxides, that's your carbon dioxide, your nitrogen oxides, and your sulfur dioxide. Non-metal oxides give acids, metal oxides give alkalis, and anything that's insoluble doesn't do anything. So that has been non-metal oxides and metal oxides as the sources of acids and alkalis. I will catch you next time where we look a bit more detail at what is actually going on that makes a solution acid or alkaline.